So Mrs. Leeson gets to admit more mistakes, and no one caught this. Well, yesterday we went through, and we were going through this quickly, and we're like, oh yeah, we figured out the perimeter of the square was 5 plus 5 plus 5 plus 5, right? And so the perimeter that we're looking for, or the circumference, we knew that this was 20 feet, right? Like that's obvious for a square, I think.
Oh, and I'm guessing we found the perimeter for the circle.
Well, no, that was fine. Like perimeter or radius of a circle, we know that to find the radius, it's 2 pi r. This was 3, so this was 6 pi, which ends up being, if we have a calculator handy. Oh, no one has a calculator handy? Let's hit the way.
18.8.
Because I'm having a hard time comparing. I just know that it was a good number for us. It was 18 point something.
Yeah, it was 18.8.
Okay. And the rectangle was really obvious too. Okay, 8, 3, 8, 3. So 8 plus 8 is 16 plus 3 and 3. I have 22 feet for the rectangle. But I ended up with this weird number that didn't match theirs. And no one called me on it because sometimes your brain just goes, it gives you something other than what you need. I had drawn a picture yesterday for this class where I had this formula that had the half base times height. Does that sound familiar? Where we said, okay, this is the height and this is the base. Because that's what we do when we have like other kinds of triangles. But we weren't looking for the area. This is to find the area. And we aren't asked for the area. I need to find the perimeter. I need to go around all the outside. So this was never going to work. It gave us a number that was close, but it wasn't the same because it wasn't what we were looking for. Okay? So what we needed to do here was we needed to figure out the length of each side, and in order to figure out the length of each side for the triangle, we have this right triangle. They said that each of the legs was 6. How do I figure out the third side? Exactly. And that's what they did for us. And I didn't know why they did that. I'm like, why didn't they use because I had a completely wrong formula. Okay? Teachers make mistakes too, all the time. Okay? Because there's so many different things we're all thinking about, trying to get all of our work done, just like you guys. Okay? And so all I can do is every time I make a mistake, call your attention to it to go, hey, I don't know why I did perimeter, area, perimeter. Like, I still would have ended up, I think, with the right answer because we were in the right ballpark. So a squared plus b squared equals c squared. So this is 6 squared plus 6 squared equals c squared. Okay? What we end up with is 72 because we have 36 plus 36 equals c squared. C equals the square root of 72. What's the square root of 72? Is there such a thing? It's probably going to be a decimal, right? But now to get the perimeter, all I need to do is say 6 plus 6 plus the square root of 72. And what do we get? 18 point...
No, it's like 8.4.
Oh, well, 8.4 for this, but we have to add the other 6 and 6.
Okay, it's 20.4.
20.4. So, in order to see, what was the maximum that I could do? 20 feet, too much. 20.4 feet, too much. 22 feet, too much. we still would have gotten the right answer, but we would have gone about it the wrong way had we just gone with Mrs. Leeson's mistake. Okay? Do we follow? Does it scare you or does it help you to know that teachers make mistakes too? Both? Honestly, I feel that way. Like, if my teacher were making a mistake, I'd feel like, they're teaching us and they make mistakes. The important thing is, though, that we understand why we're making the mistakes. That we acknowledge that we are making the mistakes so that we can do better. Okay, for all of us. It's okay to make a mistake. It's not okay if we don't try, and it's not okay if we just ignore that we've made a mistake and we don't try to understand it, because it's never going to get any better. Okay, like I could have just ignored this from yesterday and said, oh, let's just keep moving. But no, it's like, why did our things not match? Well, that was my fault. And I will admit, sometimes the book sometimes has mistakes too, and I have to go through and double check and I'm like, no, I really don't see, like, they had a misprint in this. I don't know how they got that answer. Okay, it does happen on both counts. Okay, so we're gonna, I guess, flip through these slides kind of quickly, these next couple. This is just going to go through their reasoning of how they got their answers. And I'm gonna get this out of the way. Okay, so they say you're asked to compare the perimeters of the 4 different shapes. We have to solve for each of those. So the square, all I have to do is 4 times the length of a side, which is going to be the same thing as adding up each of the 4 sides. Circle 2 pi r, and that ends up being 18.85 feet. The triangle, we have to use Pythagorean theorem because I need to know the hypotenuse. I don't need to know the area. That's not what they asked for. And so they go through and add that into that for the perimeter. So 20.49. And then the rectangle, twice the length plus twice the width. Or I can just add all 4. Either is acceptable. Both are a way to do it. And you get 22 feet. So the only shape that there was enough tape for was the circle. So B. Okay, how do we get this answer? Where do we even begin? It says, which of the following shapes has a perimeter of 88 inches? And which one has the greatest area? So I have to test all the different options, right? Okay, if I have a rectangle and has this length and this width, okay, I know that my perimeter has to equal 2 times 26 plus 2, I'm going to keep it on the outside here, times 18. So when I plug that into my calculator, what do I get, Trina?
Oh, you get 88.
I get 88. So far, perimeter is good. So now I need to figure out what's the area. How do I figure out the area? This is just length times width. 26 times 18. 468. Okay, now we have a square. Is the perimeter going to add up? 22, 22, 22, 22? Perimeter's good. Area is going to be really 22 times 22, which is
484.
484. Okay, so this one is already looking bigger. right triangle with a leg length of 26 inches. Okay, perimeter. We have to figure out the perimeter once again. So I have to do that A, B, C, where I know that this is 26, 26. Okay, so I need to figure out the C to see whether or not it's going to work. 26 squared plus 26 squared equals C squared. So what's my C?
1,352.
Okay, is that the square root of it? Have you done the square root of that number yet? I think you have C squared. We need the square root of 26 squared plus 26 squared.
I got 36.7.
Okay, 36.7 is what she has for C. I need to add in the 26 and the 26 from earlier for my A and my B. So 52 plus 36.7, does that equal 88? It's close, but it's a little short. Okay, so I'd be like questioning, like the perimeter seems too short on this one. And then this one, the circle, I need to find my perimeter, or really the circumference since it's a circle. Okay, perimeter, actually I really should say circumference. I wanna put a P, but they said, you know, one or the other. It's a special case for the circle. 2 pi r, which is 2 pi times 14. What does that calculate to? $87.9. So again, it's a little bit short. But they're saying it is about. Okay. I need to find the area. Area for this is pi r squared, which is pi times 14 squared. So 14 squared times pi.
615.
Ooh, 615.7. Now we didn't find the area for this one because we thought, well, hey, this was short, maybe this wasn't an answer. It's looking like we need to do that in both cases. I don't know for sure whether or not we have a mistake or whether this is correct, so let's come back and we're going to find the area for this one. Okay? Area is going to be base times height divided by 2, which is 26 times 26 divided by 2. So my area for the triangle is
338.
way smaller. So when they said about, we didn't need to be exact, and they say this is where we need to be. It has a much greater area. It's amazing how we actually end up with such a greater area with that circle, and we're not worried about trying to fit it within those sides. Okay? So now we're on to something new. We're back with using the coordinate plane. Get comfortable with that coordinate plane. It is not going away. Okay, we have our x-axis and our y-axis once again. And it says we need to find the perimeter and the area of this pentagon. Now, is this pentagon regular or irregular? What does it need to have to be regular? No, it has nothing to do with concave or convex.
To be regular, it has to have none of the lines going through the middle.
Nope, that has to do with concave and convex.
Oh, the lines have to be congruent.
Yes, we need segments that are congruent, we also need angles that are congruent. Richard, if you need to, just stand up over there for a bit. Okay? So these are not the same lengths. These are not the same angles. This is an irregular polygon. Why do we still call it a polygon? Pentagon.
Because it was 5 sides.
Because it has 5 sides. So irregular, pentagon. Now, to review that, concave, convex, if I extend these lines, are they going to cross through the middle?
No.
No. So this one is
Regular.
Yeah. Oh yeah.
Oh.
meaning it's going to scatter everything outwards.
This problem, don't we use the square root and then x2 minus x1 and then y2 minus y1?
To figure out the different pieces? Yes.
But then it's with A and B. And then
Yep, because what we're going to need to do, I hadn't got there yet, but yes, you're on the right track. He's starting to solve it because he says, okay, we need to find the perimeter. So the perimeter is going to have to be AB plus BC plus CD plus DE plus EA. Okay, all of those segments, AB, BC, CD, DE, EA. Now this one's easy,
Yeah.
right? This one's easy. These ones, not so much. We have to figure out how to add those bits. We have to figure out how to find those bits, right? So this is going to be really important to know. And the same thing is going to be true when we need to find the area. Okay, in order to find the area, I'm still going to need to know the lengths of those sides and other things. So let's see where we go next. Step 1. It says by counting the squares on the grid, we can find what CD is. Okay, and what DE is. Those were the two that we said, hey, that was just easy. I can just count over like I'm Dora the Explorer, following the number line. Okay? And then we use the distance formula, just like Fernanda said, so that I can find my distance on a coordinate plane when I'm going in these weird diagonals. Okay, so AB, they tell us, doing this x2 minus x1 and then squaring it, and then y2 minus y1 and squaring it, and then taking the square root of the whole thing, we end up with 5.7. So let's kind of keep track of it over here. We have AB, we use the distance formula, and we know that to be 5.7. BC, once again I have to use the distance formula. Now do we need to go back to find these points on the coordinate plane? Are we comfortable with finding our points on the coordinate plane at this point? Mostly? Okay? Just remember that whenever we do that, this is 0, 0. That if I'm going this way, on the x-axis, it's positive. This way is negative. If I go up on the y-axis, this way is positive, and this way is negative. Oh, and I forgot to add our 4.1. There we go. So BC was the same thing. We're using the distance formula, 4.1. Okay, EA also needed the distance formula. And that is going to equal 4.2. Now what were the numbers that we had for those other segments? Because we still needed the CD and DE, we just had to count over. Right, and this was just count really it's using that distance formula on a number line, which was, hey, take the value at the one point, subtract the other point, take the absolute value of that. That's what you're doing when you're counting on the number line. I'm gonna backtrack to make sure that we have those numbers. Let's go with this. So here, no, it actually doesn't tell us. Okay, so they told us by counting, CD was 6 and DE is 5. Okay. So let's look at that perimeter. I just want to make sure all of our numbers match up. So now I add all these together. Okay, perimeter is equal to 5.7 plus 4.1 plus 6 plus 5 plus 4.2. Add all those together,
25.
then you get 25. Okay? Now, in order to find the area, it says we need to divide this pentagon up. Okay, we're going to divide it into 2 triangles and a rectangle. So here's our triangle 1. And there's our triangle 2. In order to figure out that area. What do you think we're going to do next?
Pythagorean theorem? Right.
So you're thinking maybe using some Pythagorean theorem to figure things out? I think that that is a distinct possibility because we need to know, do we? We know this distance. We know this distance. We know all these ones on the outside, right? Now, actually, we don't really know this distance. We know this whole distance from here to here. We know AB. Huh.
Well, that's still a distance.
It still is a distance, but in order to figure this out, and where we're trying to figure out our area, can I figure out the area of the square very easily? Or rectangle, I guess, really?
Well, yeah. Pretty sure.
That's pretty easy to figure out the area there.
Yeah. We just
Okay.
do 5 times 6.
So rectangle is length times width. So this is the area of the rectangle, length times width, which is just simply 5 times 6, right?
Yeah.
Okay. Can I figure out the area of this triangle?
Yes.
How?
Well, okay, do you mean like the whole triangle or one side of it?
Well, I need the area.
Okay.
Can I figure out the area?
Well, yeah, because it would be just, you would do, you would use the numbers 4.2 and 6, because CD
Okay, so
is,
Nathan says I can use the 4.2 that is here.
and then 6, since CD is basically the whole length of the triangle. Like, already.
Okay. How do I figure out the area of a triangle? Area of a triangle is base times height divided by 2.
Oh, okay.
What is my base in this case? 6? What's my height?
4.2.
No, it's not 4.2.
Is 4.2 your width?
It's neither. If I have a triangle that looks like this, this is the base from here to here, and this is my height from here here. True?
Yeah.
Do I know the height?
Yeah, height is 3. So it's just 9.
Now we have that third triangle. We know the length of one side.
Yeah, its base is 5.
Okay, so in this case, we don't even have to worry about this. Once again, we have a base, right? That's pretty horribly drawn. Once again, we have a base and we have a height. It looked a lot scarier than what it really is. So this is the area of the next triangle is base times height divided by 2. Base is 5, height is 1. So what do I do now? What could I do in order to figure out the area of this pentagon? I need to add up all 3 areas, right?
Yeah.
So 30 plus 9 plus 5 halves. So this is really like 40, oh, yeah. 39 plus, and this is really 2.5. I should end up with 41.5. If we've done this correctly. Let's take a look. Okay. It says find the area of the triangles. We're going to try to leave that up on there. Area of triangle 1, base times height. Looks pretty familiar. Looking pretty good. Area of triangle 2, base times height divided by 2. Looking very good. Area of the rectangle, length times width. And so we add them all up. And we did it! Without being told first how to do it, because all we had to do was figure out, okay, let's break this up into some smaller problems, and then we're gonna add these together. And I admit, like, when I first saw this one, I was like, ew, that looks messy. But it's not bad when you realize every time we do a triangle, it's base times height, divide that by 2. Or 1/2 base times height. Okay? So let's try this one. Let's try this one. We have a quadrilateral. Is it regular or irregular? Irregular. It's a quadrilateral because it has 4 sides. Do you think it's convex or concave?
Convex.
Convex again. Nothing's going to be pointing inwards. Okay. How can we break this into some smaller pieces? Where would you even begin?
Well, there's you can just we're looking for only the perimeter.
Oh, we're only finding the perimeter, you're right. Perimeter. So what that means is I need to know what's the length of XW, XY, YZ, Y, and WZ. Is there any of those that's easy? Not really. What am I going to need to use? Distance formula every time. Okay? Distance is equal to the square root x2 minus x1 squared, y2 minus y1 squared. So the first one let's try to do this with these points in order, okay? So WX, we're gonna do this segment first.
Wait, WX is the other one. That's W's.
You're right, you're right. Thank you for catching that, because we would have been looking at that later going, what? Okay, WX, since we're gonna deal with these first 2 points. So I'm gonna put in WX, so I know which one this is the distance for. My X2, okay, X is here, that's my point 1, W is my point 2. So I'm gonna go 2, subtract -3. And I have to square that. And then my Y2, 4, subtract 3. Square. And I have to put my square root back in. Okay? 2 subtract -3 is 5. 5 squared is 25. 4 subtract 3 is 1. That's 1 squared. Make sure that we put those square roots in. Okay, how much is the square root of 26?
Um, 5.0.
5.0, it's exactly 5.0 what?
9.
Okay, 5.1. Remember that you always need to round up if the next one is higher, 5 or higher. Okay? So 5.1 is our WX section. Let's look at our XY. XY, square root. Okay? X is coming first, Y is going to be second. So -1 subtract -3. I square it. Okay. My Y's 3 subtract 0 squared. -1 subtract -3. Well, if I subtract a negative, I'm adding to the first number. The -1 plus 3 is 2 squared. 3 minus 0 is 3 squared. So I have 4 plus 9, square root of 13. What does that equal? Okay. Can we do this for the next one? Now we're up to YZ. Okay. Y is coming before the Z. So this is my point 1, this is my point 2. So 3 subtract -1 squared plus -1 subtract 0 squared. 3 subtract -1, that's like saying 3 plus 1. So we have 4 squared. -1 squared it is 1. Well, this is, let me write that up for you guys. -1 squared, which means that this is 16, 17. What's the square root of 17?
4.1.
4.1? Okay, so we have 3 sides now. Okay, our first 3 sides, we have 5.1 plus 3.6 plus 4.1, and we have to do the last one now, ZW or WZ, square root, Z is our second point, 3, subtract 2, and then -1, subtract 4, 3 subtract 2, I end up with 1 square, -1, subtract 4 is -5. Okay, so I have the square root of 1 plus 25, which is the square root of 26. And what is the square root of 26?
5.1.
Which is exactly what we got earlier. It's amazing how that actually ended up being the same length. And we add all of those together to get a perimeter. What do we get? 17.9.
Yeah, 17.
Painful. What's painful about it?
So much math for
But was it hard?
Just
It's tedious. Sometimes math is tedious. We all knew right away, Fernando picked up right away that, hey, I need to make use of that formula. And all you did was make use of that formula again and again. And you have to be very careful making sure that you're doing the x2 minus x1. And then square it. And then this one, and square it. And then take the square root of that. Like, you have to make sure you have all those steps. Is it hard? No. Is it tedious? Yes. And you have to stay focused long enough to see it through. But you guys can do this. So that's it. How much time do we have left today? Finally. 10 minutes?
Yeah, just about.
Okay, what you want to do is get started or look again at your homework, which is lesson 1-6, which is going to start on page 61. Okay, so we're at page 61 or lesson 1-6. Get that to come down a little bit, yes. Okay, from the textbook. I'm asking you essentially to do 11 through 41 odd. But you can skip number 33. Was there any particular ones, Trina, as you started going through it, that were giving you any difficulty? Which one?
The last few ones where it was like, find the perimeter if it gave you the area or something.
Okay. So what you have to do with those is you have to work backwards.
Yeah, but
Okay. Let's take a look. So, can you tell me a specific number? Because the very last ones aren't that they just give you a shape and they give you a side and they tell you to find the perimeter and the area and round to the nearest hundredth. Okay, are we talking like 35, 37, 39?
Yes.
If you remember? Because those, it says find the perimeter and circumference, and it gives you the length of this rectangle is half the width, the area is, and the next one is the area is, and the one after that, here's the, that the length is twice the width, here's the area. So those are the ones that we need help on. Okay. Let's take a look. Okay, question 35. Let's start with that one. Okay, so we need to find the perimeter or the circumference. And in 35, it says that the length of a rectangle is half the width. So I have a rectangle. And we know that one side is twice as big as the other side. Right? So we're gonna say that this is like x, and this is gonna be like 2x. Okay? Now they tell us that the area is equal to 25 meters squared, and we need to figure out the perimeter. So we need to really solve for x, and then plug that x back in so that we can find the perimeter. How do I find the area of a rectangle?
You multiply length times width.
Okay, so we have length times width is going to equal 25 meters squared. Do I know the length?
No.
Do I know the width? I do, in the fact that I know that this is going to be x times 2x is going to equal 25. So 3x equals 25, and x is going to be equal to what? 25 divided by 3. And I could use that. I don't have to put it as a decimal. I could continue with that, but some people are uncomfortable with the fractions. Okay? I put this back into here. That means that this is now 25 over 3, and this is really like 50 over 3. And I have to constantly add, or do 2 times this plus 2 times this. Is it solvable? Was it quite as bad as you thought?
No, I just.
What did you think at first?
I thought I was like panicking because like I wasn't sure how to go backwards.
Wow. Does it make sense to go backwards like this? Okay.
What's a shape with 11 sides called?
I honestly don't know.
I got it. Hendecagon.
Undecagon?
Hendecagon.
Undecagon?
Hendecagon.
And yeah.
Can you spell it?
H-E-N.
Hendecagon.
Yeah.
Hendecagon. I'm sorry, but there's still some things that I need to look up too. Okay, that's 11 sides. In case you needed to know.
Well, we should watch that one song that Miss Goddard used to play for us. It was like, I wish I was not too long, but I was a square.
Yeah, that sounds pretty cool. Do you want us to go through like 37, 39?
Yes,
At least to get it started?
yeah.
I figure if we have a couple minutes, which we do, I think it's a good thing to do. Okay, 37, once again, we're finding perimeter or circumference. What are we given? We're told we have a circle that has an area of 25 pi. So we have a circle. We don't know its radius, but we do know that the area is 25 pi. Okay? Well, we know that area is pi r squared. So pi r squared equals 25 pi. I can divide pi out of both sides. And I'm left with r squared equals 25. Well, the square root of r, or sorry, the square root of this is just going to be r. Square root of 25 is. Am I done?
No. 'Cause it's
What do I need to do?
You need to find the circumference.
I need to find the circumference. So circumference is equal to 2 pi r, which is 2 pi times 5. Not so bad. I'm surprised by the number of people actually not taking this down. Like, you guys are getting answers. Just saying. Okay? 39 is the same pretty much as 35. I end up with a square. Oh, sorry, rectangle once again, where we have x and 2x. And it tells us that the area is 48 square inches. Area is simply length times width, which is x times 2x equals 48. 3x equals 48. X equals 16. Am I done? No. I have to put this information back into here again. So this is like saying the sides now are 16, 32, 16, 32. Can I find the perimeter? Yeah. This seems way easier than when we have to do the giant square root, huh? It's less tedious, okay, but just as important. So I actually did extend this out, like if you get this done today, great. I extended it out for another day because of those people that are at home. So get it in by tomorrow and everything is good. Tomorrow we're gonna start on lesson 7 because next week we need to have one last test to finish up this chapter and move on to chapter 2
Wait, so when is it specifically due?
tomorrow.
When? Tomorrow.
Sometime tomorrow.
Okay.
I've given up on times.
Can I take a picture of this?
Yes,
Thank you.
you may. No one was paying attention to the times anyway, so I give up.
No, you couldn't tell me it said due 11:59.
Yeah, that's what it's just constantly doing. It's due that day.
Alright.
The sooner you get it in, the sooner I can give you guys feedback. Which is my ultimate goal, is to give you guys feedback. Which is really sad if the feedback is, show your work! I see nothing! I can't give you feedback. I can't tell you what you're doing wrong if there's no work. Show me your work. You get much better grades by showing your work. And you understand it a lot better by showing your work. And sometimes that work will take up half a page. Let it go. Okay, we're not using that much paper nowadays that there's like a major shortage or anything. A lot of stuff is happening on the computer, but math is still so much easier writing it out.